Today we are going to discuss about buffer action. First of all, what are buffers? Buffers are solutions that can resist changes in their pH value when we are adding a small quantity of acids or bases to that solution. So they will be able to resist any changes in their pH values whenever we are adding a foreign substance to it. So, and what is buffer action? This resistance to change the pH of a value of a solution is known as buffer action. What are the examples of a buffer solution? If you are taking an acidic buffer consists of a weak acid and its salt. For example, acetic acid is a weak acid and its salt is sodium acetate. So acetic acid and sodium acetate is a combination of acidic buffer. What about basic buffer? It is a combination of weak base and its salt. For example, ammonium hydroxide is an example for a weak base and its combination with ammonium chloride can be an example for a basic buffer. Now coming to the most important point about how this buffer action is taking place. For example, take a case of an acidic buffer. As I already told you, example is acetic acid and sodium acetate. And the ionization of acetic acid is taking place like in the equation that I am showing. And in this equation, you can see the ionization happens and H plus and CH3CO minus acetate ions and hydrogen ions are forming. And when we are adding is another substance like a strong acid like HCl is adding to the system, the equilibrium is kind of disturbed, and you have got H plus ions, more quantity of H plus ions is forming there. And as a result of that, since there are a lot of H plus ions, these started combining with the CH3CO minus, and it is equilibrium is shifting back to the backwards. So CH3COH is more formed. So this, whenever we are adding this acid, that is being neutralized by the acetate ions of the mixture, and thereby this pH can be maintained. pH can be constant. So this resistance of a change in the pH of a buffer solution has got many applications. One is the pH of the gastric juice in the digestion of food is always maintained between 1.6 to 1.7. So that is an example for a buffer action that is happening inside our body. Another example is the pH of the blood that is maintained at around 7.4. That is because of the buffer action of sodium carbonate and carbonic acid. So the buffer and its solutions can find many applications inside our body, and many other applications are there. One more point or one more term that you should be familiar while studying this is buffer capacity. It is defined as the number of moles of acid or base added per liter of solution to change the pH by 1 unit. So buffer capacity is defined as the number of moles of acid or base added per liter of solution to change the pH by about 1 unit. So these are the basic points that you should remember while studying buffer and a buffer action. Thank you.